If everything is fine, this easy spin motor is expected to run for 5 years. Current consumption is 25 microamps. This 3D printed rotor diameter is 40 millimeters and the axis is from bicycle spoke, sharpened on grinder, and we have magnets and Gorilla Glass piece from broken mobile phone. Coil resistance is 16 kilo ohms. Circuit consists of 2 transistors. Altogether there are 3 parts, 2 transistors and 1 large resistor. In my case it is now 10 mega ohms. And coil resistance is 16 kilo ohms. I probe current by measuring voltage across 1 kilo ohm resistor, and it is about 7 microamperes at 1.5 volt. And we see quite now supply is 0.7 volts, and we see that there is asymmetry in rotation because rotor is not balanced well. And on oscilloscope trace we see 3 peaks where we have generation and 1 peak where it is too slow. Now we are at 0.8 volts. Motor has stopped to make full turn. And we see induction only on 1 spike. In this mode the motor is going to stop. 0.3 volts, motor starts to turn around and it's accelerating. At 4.2 volts it spins too quickly for camera to resolve. About 20 microamps from half empty lithium cell. Red LED flashing in the dark. I was puzzled why it is better to get a coil with larger resistance. Mendocino motor 110s, 0.2 millimeters, about 10 ohm resistance. Solar rocker toys, they have 500 ohms, very fine thin wire. And my handmade easy spin motor, 70 micrometers wire, got 550 ohms times 12 coils, it was 6 kilo ohms. Microwave motor, which turns the turntable, it has very thin wire, and it has 12 kilo ohm resistance, which is also higher, better than can be made by hand. And the best is 380 volt motor relay coil, blue coil with higher current commuting, it has 15 kilo ohms, and red coil has 35 kilo ohms. One of YouTube enthusiasts, Theodore Pali, was making amazing coils with very thin gauge wire, and he could get 130 kilo ohms per coil. And other YouTubers used 12 coils in series, and if they put coil from such relays, then they can get 300 kilo ohms. What we care actually, it is magnetic force. We have, for example, permanent magnet, and here we have coil, and they try to interact. And the magnetic force is proportional to the current and to the number of turns. And also geometrical overlap factor, how close are the coils near each other. So let's assume we make 2 times more turns on a coil, so resistance increases 2 times, and we want constant magnetic field. So in the beginning it was n times current, and afterwards it became 2 times then, and current we need only half of the previous. What happens with the power? Power is voltage times current. We have half of the power, so twice less power needed to produce the same magnetic field. But more turns, it means larger coils, and there is at some point no more space on the coil. And now let's assume we take thinner wire, twice thin, So we have in the same place 4 turns, and number n goes from n to 4n. The length of wire becomes 4 times longer, and specific resistance becomes 4 times larger because it's thinner wire. So the resistance increases 16 times the initial, not just 4 times but 16. So then we want constant magnetic field. In the beginning it was current times number of turns. Now it became 4 times number of turns, and current can be 4 times less. So the power in the beginning it was current times voltage, and now it became voltage times current divided by 4. So the power is 4 times less at the same magnetic field force. So it is good to have thinner wires for the coil. And I wonder what will happen in the extreme case when the wire would be just so thin that electron can pass. Then it would be some theoretical limit for the super thin coils. So the thinnest gauge wire nowadays it's number 50, and it is 1 micrometer in diameter.